Okay, so when we start with the examples, let's see the first example here, which is basically associativity of relational operators. That's the name of the file. And here what we see is basically some code where it starts with the standard hash include IOStream. Then we use the namespace std for scene and see out, of course. And here is a very simple thing. It's basically showing that if, for example, we ask the user to enter an integer, he enters one number, and we check if that number is between 0 and 10. And if that is true, well, ideally, we should actually display, if that number really is between 0 and 10, it should ideally display that number and say that that number is within 0 and 10. All right. Otherwise, it should say number is not within this. So we are checking that whether number is within a range, and we have used this particular formula. But here's the problem. So when we run it, what will happen is that ideally, for example, you enter the number 5. That 5 is between 0 and 10, and you should get 5 is within 0 and 10. Period. That's fine. Right. So, and if you enter a number, let's say 15, 15 is greater than equal to 0. Yes, that's true, but it's not less than equal to 10. And hence, ideally, we should go to the else and we should mention that 15 is not within 0 and 10. But if you notice this thing, if I run this code and I'll input the number 15, as you'll see here in a minute, um, uh, even if I enter the number 15, it is going to, it gives me a warning here, something like type bool is always true. Okay, it's giving a warning, strange warning. Why is that happening? But let's see if I enter the number 15 and it says 15 is within 0 and 10. So this is still running, although I actually gave the input that I gave here is not between 0 and 10. And it's kind of amazing that it's asking me that 15 is within 0 and 10. Why is that happening? Well, okay, let's enter another number that's a negative number. Okay, so we run the code again and we can run it like here. And if we run it, it now asks us for an integer, and I now give it, let's say, negative 20, right? And this time it says that negative 20 is within 0 and 10 again. So whatever I enter, this is always, always, always going into this particular if loop. Why is that happening? That is happening because of the reason that uh, if you look at it, if you look at these less than equal to signatures, we know that this less than equal to has the same priority as less than equal to. So both have the same precedence. And when both have the same precedence, it's the left one that is getting evaluated first. So the computer by default is actually evaluating 0 is less than equal to your number, whatever that is. Of course, it is either true or false. Let us suppose that it is true, right? Then and 0 is actually less than equal to the number. For example, if you enter the number 20 here or 15 here, 0 is less than equal to number 15. If something is true, it returns value 1. So this whole part will be replaced by the value 1. And is 1 less than equal to 10? That is true. Yes. Hence, we are going to output that whatever that number is, even though it was 20, it is within 0 and 10, which is not true. On the other hand, when I enter basically a false number, for example, when this condition becomes false, for example, let's say if I enter a number minus 20, then this condition is false. 0 is not less than or equal to minus 20. Hence, when something is false, or the Boolean value that is returned, or the integer Boolean value that is returned is 0. So this returns 0. 0 is less than equal to 10. Yes, it is also true. Hence, even minus 20 is between the range. So when you're using the associativity operators like these, when you want to define something in range, you must always use um, two different if conditions to match. So it would have been better to write if 0 is less than equal to num, and inside that another if that says that if num is less than equal to 10, and then you should output that number is within range. Otherwise, number is greater than the range, else number is less than the range. So that way we are always safe. And if you do not understand the associativity rules or something, we must always use braces, like I said. In a standard computer program, this will always be returning true value and incorrect value. Hence, you should avoid this. So this was one example which should be avoided. Let's go to another example, which is basically average average test score. And in this case, we are seeing a bit long file. It's basically a program that calculates the average test score of a person. So you actually take 5 tests, you enter the number of 5 tests, you want to calculate the average. And this is one typical example where we're again going to use the file stream operators, the input file operator and the output file operator. So in this case, we basically use the string first name and last name. So input file again that we're going to use is the same standard text test.txt that I used in the last lecture. It contains the test results. If it cannot open it, if not in file, so if this is not true, then we should output that we cannot open the input file, the program is going to terminate, and we could return 1. Return 1 means that there was some kind of error, it's not normal. Otherwise, if this is not true, and you can notice that the return statement here, what this does is that it returns back to the main function, or it returns away from the current function. In this case, since this is already the main function, so we're going to quit the program. When this condition is encountered, we first output the error message and we return, we just quit. Similarly, open the output file. Okay, and here what we are doing is we are fixing the manipulators so that we get the results accordingly. Then we start processing the data. Input file, the first two strings that are found are going to be put into first name and into the last name. Then in the output file, we basically display that the student name, first name, space, last name has been found, and we put a next line character inside. Then we again process and basically read the next 5 scores, which are the test scores, right? And then in the output file, we write the test scores accordingly based on certain width. Finally, we calculate the average from whatever scores were read in this particular part. We'll just calculate the average by adding them up and dividing them by 5. Standard code, nothing complex here. Then we finally output the average score by writing in the output file as output average test score is set with 6, and average, this is just the precision part, or basically the manipulator part. And here we just output the average and then end, and then basically close both files and return 0, end the program. So this is the whole code. If you run it, I think you might be able to see the test.txt file here. So test.txt contains Andrew Miller 87, 89, 65, 37, 98. We want to read this file. It's in the same directory as this one, so it's very easy for it to find and read. So let's basically just run the code and see if it is able to find the average and everything else. It's going to compile the code. And finally, it shows us our score off. It processes the file, does everything, and basically creates a file here, which is testaverage.out. Let's see what that file contains now. It contains student name Andrew Miller. Test score is 87.00800, and then you've got it 9.00, and then 65.00, and 37.00, and 98.00, and the average test score is 75.2. So basically, this amount of space you gave was not enough for us to see, and maybe for that reason we are seeing them combined. But these are the scores, and this is what happens with the precision. So this is just again the standard code, nothing really complicated here. And yeah, so this is the second example where we actually calculate the average test scores, and you can give it any score, any person, any number of persons as well. So this is just, although this is made for just a single person, but we can, in computer programming, we can always make a program that work for multiple persons, and we'll see that in the maybe in the next lecture as well. So let's go into the next example, which is about the break statement, the effect of break statement in a switch structure. In this particular case, we are again using the standard header files, the standard preprocessor directives. We get into the function main, we declare a function num, an integer num. We output that enter an integer between 0 and 7. And then we input that number, and we then output the endl. And we find that the number we have entered, we verify that the number that we have entered is this. Now, if the value is, if you read this particular program, it basically says that if the value is 0 or 1, you should output learning to use C++ soft switch structure and go to the next line and basically break and get out of the function and output out of switch structure and then return 0. However, if you enter 1, it's still the same. So for 0 and 1, it's basically these three lines that we output. For if you enter 2, you'll just output C++ switch structure. If you enter 3, you're going to output switch structure and break. If you enter 4, you're going to be out of switch structure, will be displayed and going out. If you enter 5, you'll be outputting this program shows the effect of the break statement and then out of switch structure and gone. If you enter 6 or 7, it's going to output of the break statement and gone, out of statement switch structure and gone. And if you enter anything else, it's going to be entering here and going out. So let's run it and let's try to enter some of these values. Let's try to enter, first of all, let's enter 0 and 1 just to see the effect of, there's no break statement here, right? There's nothing here. So it will automatically go into next cases. And this is what you need to understand. So let's say if I enter 0, right? So what I get is, if I enter 0, learning to use C++ switch structure out of the switch structure and the end. So it basically, when I entered 0, it basically shows all of these. It went on to learning to use C++ switch structure. That's a line here. And this basically means that if you don't have a break statement, it's going to spill over into the next case, until it encounters the first break. That's what I told you in the corresponding region as well. So this one is again shown here. So let's run it again and let's try to enter. This time I'll enter 1 and you'll notice that the value that I observe now is still the same. Learning to use C++ switch structure, it's exactly the same as the previous one. And so even with 1, it does the same thing. But this time let's try and enter 2 actually to see what is skipped and what happens here. So now if I enter basically 2 here, you'll notice that now it's C++ switch structure. So instead of getting the whole line learning to use, this part was skipped. Basically what is happening is when I entered number 2, it matches this one, does not match, matches. Where it matches, it starts to execute it until it encounters the first break. No break here, spills over here, finds the break, goes out of the loop, out of switch structure and out. So we notice that with 2, we are going to observe C++ switch structure. If you enter 3 on the same line, we basically observe that in this particular case, we find that switch structure and out of this. So even C++ is gone. So whatever matches is going to be printed. So what happens when we actually enter 4 here? And that's the most interesting part. If you try to enter 4, you'll notice that we'll just directly go out of the loop, out of the switch structure and gone. So if you encounter the first break, exit the loop and we are out. Similar case for maybe 5, 6, 7, you can kind of guess. You can pause, you can run it on your own and see what happens when we enter 5, 6 or 7. If you enter 5, you'll observe this program shows the effect of the break statement, out of switch structure, gone. If you enter 6 or 7, you just get off the break statement, break and gone, right? So you need to understand the difference between 5, 6 and 7 and what they are doing here, right? But let's try it for actually something else, which is the default here. So the default is any value that is not between 0 and 10. So let's say if I enter -1, which is not in the range, it will go into the default. It was going to say the number is out of range and then out of switch structure, and then it's gone. Similarly, if I try to enter, let's say, any other number, let's say I enter E. In E, it says the number that I've entered is 0. So no number was entered. Of course, I cannot enter a character instead of a number. And in that case, it's saying that the number was 0. And it goes on to learning to use E's C++ switch structure and so on. So that's a bit of a bug here. You need to be very careful with 0. Anyway, let's run it again. And this time, let us enter a number that is, let's say, 10. And this is again out of range because it's not, it's a number and it's not within these particular set of days. So it goes into default, executes it and moves on. So that is an example for default and for break statement. So let's try to the next. Let's go to the next example, which is cable company billing. This program calculates and prints a customer's bill for a local cable company. The program processes two types of customers, that are residential and business, and it thus calculates the bills. So this is a bit of a long code, but I'll discuss it in a minute. So let's suppose that we basically actually start with the standard preprocessor directives. Here are some of the global variables, right? And what the global variables are, I'll kind of explain them in a minute. These are global but constant variables. So like I said, you can actually declare variables that are outside the, like I've actually discussed already with you in the class. Um, these are constant variables, so they're all declared in caps. So you can see, for example, residential bill processing fees, residential basic serving cost, residential cost, premium channel, and similarly the bus bill processing fee, bus basic serving cost, blah blah blah. So these are all the things, and these are named constant for residential customers. So you can basically see residential bill, residential basic, residential cost, and these are for the business ones that all start with biz. So business, 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 and so on. These are the costs, and these are mentioned outside and main. Just a reminder that that's why these are global. So once a thing is global, they're accessible in any function. So they are accessible in the main function. In the main function, we declare some variables. We then set the precision and set the manipulators right. Then we display that this program out computes a cable bill. We enter an account number, which is an integer. That account number is taken into the account number. Then we go to the next line. We again ask the user to enter whether it's a residential customer or if it's a business customer. Um, the the user is going to enter a customer type, and then we move to the next line. Based on the customer type, if the value is R or capital R, we then output that whether the number of what are the number of premium channels. He enters the number of premium channels. We calculate the due amount by using this formula, and then we basically see out at account number so and so as the amount due is this much, and then we end the loop and the switch statement, and maybe go out if it's a residential customer. Otherwise, if it's not residential customer, we're going to compare with R. It does not match with this R. It matches with it. If it's a business customer, it will be matching with this B or this capital B. And then based on these values, it's going to enter here, do the same process again, but this time the calculation will be based on the business customer. And here the difference is that if the number of basic server connections is less than equal to 10, then we calculate with this formula. Otherwise, we calculate with this formula. Similarly, we output the account number, and then we output the amount due, and we break, and we basically move out and return 0. If there's any other symbol entered other than small r and capital R, or small b or capital B, we actually enter the default statement, and here we're going to output that this is an invalid customer type. We are supposed to stop, and we end the switch, and we return 0 and quit the program. This is again a very simple program, a very simple setting. You don't be afraid of the number of lines here. This is very normal in C++ to have all these lines out. And here also we see that this is basically not a single line. This is basically a single line that is a single statement that has been split into multiple lines. C++ recognizes the symbol this as end of a statement, and we notice that even with this, it runs absolutely fine. So that's I'm not going to run this program actually, because this is pretty obvious what it is doing, but you can try it on your own and see that it is doing exactly what I've told you. Run it at times, and based on the previous example, we know the behavior of this program. So let's move on to the next example, which is basically which compares numbers, and it takes two numbers and basically finds the largest one out of them. So this is the standard program using if and else statement. In this case, it asks the users for two integers and verify that two integers are so and so. If the number 1 is greater than number 2, then the larger number is output. Else if the other number is output, and else if both numbers are then equal, since neither number 1 is greater than number 2 nor number 2 is greater than number 1, that means that both are for sure equal. So it's a standard program, and you can again run this code by simply just running it and basically entering two numbers. Let's say if I enter the numbers 5 and 10, right? So it says the larger number is 10, pretty good. Let's enter them in another format now, which basically says that let's enter them 10 and 5, and again the answer is the larger number is 10. So now we know where it's going in. So in this case it's going in this loop, since 10 is greater than 5, so it goes here. In the previous case it was entering, this condition was not true, it checked for this condition, this was true, and it output 1. Notice that there's only one output, so basically when you have if, else if and else statements, one of these statements is going to be executed and not all. If I had entered basically, let's say 10 and 10, my output would have been exactly what's mentioned here, that both numbers are equal, and then we can kind of stop. So that's, I think, something about the equal numbers chapter, this particular example. So in this case, we learned how to use if, else if, and else to determine the largest number among, or the larger number among the two numbers that are being input here. Of course, there are only three possibilities: either you are greater than the other number, or you're smaller than the other number, or you are basically equal. And we have catered for all three examples over here. Okay, so moving on to the next example, which is a program to compute and output the penalty on an unpaid credit card balance. The program assumes that the interest rate on the unpaid balance is 1.5% per month. So with that, we have declared the interest rate as 0.015. This is declared globally, so it's accessible here. It's named constant because we don't want to change its value whatsoever at any time within the program, even by mistake. So that's why it's a constant, and because it's a constant, it's declared in all caps as usual. So now we declare some variables. We basically set the manipulators correctly. We then output the user to ask the user that, enter the credit card balance. He enters the credit card balance. Then we ask him to enter the payment. He enters the payment. We find the balance. And basically in balance we say that if credit card balance minus payment, so whatever is the balance, we deduce or deduct the payment. If the balance is actually greater than 0, if it's positive, then you have got some penalty. So here you have paid less and you still have something left. So if it is positive, then you basically have to pay the penalty based on the interest rate. Then we enter that the current balance is so much, and then we enter the penalty, which is to be added to your next month bill is this many dollars, and then we return. So this is again standard code, but here what we see is we are going to use an if statement alone. So this is just going a single statement. And in this particular example, we see that if balance is greater than 0, then we're going to do this. Otherwise, this will not execute at all. And remember, since this is just a single statement, this if is encompassing this. A good thing that you notice here is the indentation. The indentation here clearly shows that this cout and this cout has nothing to do with this if. However, this condition, penalty is equal to balance into interest rate, is directly related to this if. So we have kind of included it into the next block of penalty, and this makes it much more readable. So let's run the code and let's see what the results are. In this case, we basically want to enter the credit card balance. My credit card balance is, for example, $100. My payment is, for example, $150, or let's make it $200. And my net balance is minus $100, and hence in the next month, the penalty to be added to my bill is $0. It's $0 because if you multiply 0.015 into 100, which is done here, where is that balance is declared as a double, penalty is declared as 0. Okay. Notice also that penalty has been initialized by 0. This is true because if this does not execute, still we are going to display the balance, the penalty, which is 0. So in this case, my balance is minus $100. The penalty to be added to my next bill should be 0.15. Why is that not happening? If balance is greater than zero, balance is not greater than zero. Okay, if balance is greater than zero, this is incorrect. Small mistake here. If balance is greater than zero, only then this is going to be executed. Actually, if you have to make more payment than the credit card balance, only then you should be paying the interest rate, right? If you made more payment than your credit card balance, then I think this should not work. But anyway, it depends on how you look at it. In this case, one way of observing this might be that, you know, in banks you have got a certain credit card balance, and if you have made more payment than your balance, you're absolutely fine, because in that case your balance is going to be increased at some stage, or you know, you basically have some extra cushion to spend in later months. However, if you make less payment than your balance, so that's the money that is kind of owned by the bank, and whatever money is owned by the bank, you'll pay um, interest on it. So in this case, it might be that the computer or the programmer is basically thinking that if there is some balance left in the credit card balance, only then you are basically going to pay some interest. If there is no balance left, if you are just doing fine, if you've paid all the money and you have paid more money than the amount that is in balance, then you're not going to be paying any penalty. So that's the thought here. I'll go by that, and maybe just move on. It's just an example. Again, we see a very small program and the use of if statement to accomplish a particular task. So this is a one-way statement. It either runs or it does not run, and there's no alternate here. So if you run it, then you move on to this statement. If you don't run this statement, even then you move on to the next statement. So let's go to the next program, which is about um, the equality of floating point numbers, and that is very interesting. This is an example that I talked about in the lecture as well. So in this case, we have got a double, notice that we include the C math library. So we have got double x is equal to 1, and then we have a double y, which is 3 divided by 7 plus 2 divided by 7 plus 2 divided by 7. By fractions, we know that this one comes out to be 7 divided by 7, which is equal to 1. So let's see the precision here. It shows a precision of 17 decimal points. 3 divided by 7 plus 2 divided by 7 plus 2 divided by 7 is equal to, we just perform this operation and we can see what the number is. Then we output the value of x, the value of y. Value of x is 1. The value of y is going to be all of this sum, which is also supposed to be 1. If x is equal to y, if 1 is equal to 1, we output x and y are the same. Otherwise, we output that x and y are not the same. So that's the first thing. However, here's another thing. If the f absolute value of x minus y, to use f absolute, you need to include the library function cmath. Otherwise, this is not going to run. If you do x minus y, and here what we're doing is, if the value of f absolute value of, without the sign, if the value is basically less than 0.000001, we say that x and y are the same within the tolerance value this. Otherwise, we say that x and y are not the same within the tolerance value this. So ideally, if you run it, you'll assume that we are going to have this one. Since, you know, 1 is equal to 1.0 is equal to 1.0, we're going to have this one, and then this is going to be followed by this one. However, what you notice is, when you run this program, you'll notice that x will not be equal to y. So hence, we are going to have this line output here. However, if you take the f absolute and you check the tolerance value, if it's within the tolerance value, it's going to output that we are within the tolerance value. And that's what is desired here. So just run the code and you're going to see that we're going to observe that we go through else and this if. So we see, first of all, look at the values. It's 1.000, they're all 1, they're fixed to 1. So this is fine, x is fine. But the bottom one is basically 0.999999989. So x and y are not the same. Of course, they're not exactly equal, and hence they're not the same. And that is happening because when you divide 3 divided by 7, you're going to get a particular double number, as you can observe at the top. And this double number is 0.4285714 something. If you go to this part this is basically again a double number, which is 0.2857 something. And if you go to this one, it's again 0.2857 something. And if you add all of these, this comes out to be 0.9999 something. And because that is happening, hence both are not equal. Because you can only have numbers up to a certain precision. And beyond that, everything else is kind of shaky. So for that reason, we are observing a 8, 9 at the end instead. And this means that after that, of course, we cannot add up in a double as well, due to its 16 or 15 decimal places that it can show. And then if you move on to the this comparison, this never works because both are not exactly equal. So whenever you are talking about floating point decimal numbers, you must make sure that, for example, you're using a double or you are using a float, you are supposed to make sure that both these numbers are within the certain tolerance value. That's the only way you can compare them. Do not ever compare the floating points in this particular manner. Okay, so then we move on to the next statement, which is basically how to correct the GPA program. And let's say how does this work? So in this case, we start with the typical header files. We move on to, we declare some variable GPA, which is a double. We want the user to enter the GPA. So GPA is this. If we say that if GPA is greater than equal to 2, and if the GPA is greater than equal to 3.9, then you are on Dean's honor roll. However, if the GPA is not greater than equal to 3.9, then you're not shown anything. You're just, your GPA is over 2. That's it. Else, and this else basically maps to this if, because these braces mean that this else is going to be mapped to this if the GPA is actually below the graduation requirement to see your academic advisor, and that's all. So in case your GPA is greater than 3.9, you'll get a message that you're on Dean's honor roll list. Otherwise, if your GPA is less than 2, it's going to be messaging something else. But this else is mapping to this if and not to this if. And it's not because of indentation. Let me be clear here. It's because of these braces. So these braces mean that this is a compound statement now. If I remove these, this else is going to be mapped to this if. Anyway, and you can notice that there's no braces here, but these ones, despite being in different lines, are a single statement because the semicolons ensures that these are all a single statement. So let's run the code. Let's enter some GPA. And the GPA here that I'm going to enter is, let's say, 3.95. Okay, so with 3.95, I'm on Dean's honor roll. Very nice. Let's run it again, and this time let's enter a GPA of, let's say, 2.8. And in this case, I don't get anything as expected. Nothing got executed because this if is not true. So this one is a two-way statement. Either this runs or this runs. But this one is a one-way if statement. So this runs or does not run. So in this case, when I entered 2.8, it entered here, but it could not execute this one, and hence nothing happened, and I moved out. But if I, for example, now enter something that is less than 2.2, let's say I entered 1.8. So in this case, it says the GPA is below the graduate requirement. See your academic advisor. This is exactly what should happen. And that's why my results are absolutely fine over here. So let's, after this example, what we now know is this else is mapping to this if and not to this if because of these braces. And at the same time, this is a one-way statement. This is a two-way statement. So moving on to the next example, which is about GPA programs with bugs, with errors. And this is the exact thing where we've removed the braces. So now, despite the indentation, like I said before, this else is actually mapping to this if. So now if you enter a GPA, anything that is less than 2, it won't show anything because now this if is a one-way statement, while this if is a two-way statement. And if you entered a statement that is a GPA that is less than 2, it's not going to show anything. If you enter a GPA that is basically greater than 2 but less than 3.9, you're going to enter this particular point, which is not true. However, if you enter a GPA that is greater than 2 and also greater than 3.9, then you enter this Dean's honor list. So let's run the code and let's see its behavior again. So this is something that you're very much warned about, this if is mapping to this, and it also gives a warning here. Add explicit braces to avoid dangling else. It might assume that this is a dangling else, but this is a warning. This is not uh, a syntax error. This is basically something what we call logical errors. Of course, the error here is that this else is incorrectly indented. And because of the incorrect indentation, one might think that this else is mapping to this if, while this is not really true. So let's see the GPA. Let's enter GPA of 1.8 and you'll see nothing happens. Exactly. Let's enter a GPA of, again, of, although this is incorrect, you're basically you cannot graduate. And it should show that message. It's not showing that. Let's enter a GPA of 2.5. And on 2.5, it says the GPA is below the graduation requirement. Not really true. It's over 2. And since it's over 2, I'm not on probation. So this is incorrect again. And if I run it the third time, where I actually enter a GPA of 3.9, that's the only time it's going to behave appropriately and give me the value Dean's honor roll. This is happening because of adding this else, which seems to match this if by the indentation. However, it is actually each else is always mapped to the last most recent if, which in this case is this one. So this if and this else are together. And this is the way it is. It gives a warning that you should add braces to explicitly say which if this else belongs to. And that's where it asks us to put explicitly braces. Anyway, moving on to the next program again, which is another great program but with bugs. Here, what we notice is we use a switch case statement. In each of the switch case statement, we basically get a test score divided by 10. If the test score is 0, 1, 2, 3, 4, 5, we say the grade is F. Then we say that if that's the way we want it to behave actually, that if the test score divided by 10 is equal to 6, we say the grade is D. If it is 7, grade is C. Grade 8, grade is B. For 9 and 10, we say the grade is A. Otherwise, we say that it's an invalid score. But having said that, it's a funny execution. When we execute it, we'll notice that we'll be outputting the grade is F, the grade is D, C, B, A, invalid test score, and then basically quit. So whatever number you enter, let us enter a score of, let's say, 10. A score of 10 is going to be converted to 1, and with 1, I basically am over here. Since this is true, I'll be outputting actually all of these, because the case quits when it encounters the first break, and there's no break here. So enter 10, and you see every grade is observed. This is what was exactly mentioned here. And that is happening because there is no break statement here, and that's why this grade program is with bugs. Once you enter breaks here, everything is going to be absolutely fine. So let's go to the next example, which is about the logical operators. And what are the logical operators? The logical operators are not, and other things. So in this case, in this particular example, we're going to include the traditional headers. We're going to introduce some variables, and let them have some values. We then see output that found is basically true. Age is so much, hours, overtime, count, ch, which is a character, is this. Not found evaluates true. So not is basically one operator, and what this is going to evaluate to be is not found, that it reverses the value of found. Let's say the hours is greater than 40 is also a condition. So this is also going to be a boolean. How does this evaluate to? We'll just output here and it is going to show us the value. The hours is greater than 40 is this. Not age. Age is now an integer. And we know that if you take the reverse of an integer of this, it's always 0. So not of age is always going to be 0. Not found and age is greater than equal to 18. So if age is greater than equal to 18, if this is true, well, this is true. Found is also true. So hence this is going to return true, and the inverse of true is going to be false. So this is going to return a false value, and so on. So we saw these examples in the code, and now we saw these examples in the lecture, and now we're just going to run it, and we're going to observe some certain values here. So what we observe is, well, not found evaluates to 0, which is false. Exactly, this is true. The opposite is false. Or is greater than 40, evaluates to 0, evaluates to 1, that it is true. Is ours greater than 40? Yes, ours is greater than 40. 45.3 is greater than 40. Not age, not of 20, evaluates to false, and that is also, yeah, true, because each integer is treated as true. So in not of it will always be 0, false. Not found and age is greater than 18. This is true. This is true. If both are true, then this is true. However, since this is false, not found is false. Hence, the oral statement is going to be false, regardless of if this is true or not. And that was what I call the short circuit rule. Not found and age is equal to 18. This is true. This is true. However, if you inverse it, it then becomes false, and the oral result is false. That's what you observe over here as well. Both are the same in terms of result, but we can know the difference. This is not for just found due to the precedence of not, followed by evaluating this, and then followed by evaluating the and. However, in this part, it's basically evaluate found, evaluate this, and then take an inverse of it. So that's the difference here. Then if you go on to the next example, is basically hours plus overtime is less than equal to 75. If hours and include the overtime, if that is still less than 75, this one evaluates to, you evaluate this part first, then you evaluate this one, and then you can move on. So that's the precedence here. And since ours is 45.3, overtime is 15, and it sums to 60.3. 60.3 is less than equal to 75, hence this is true. So this evaluates to true over here. In the second part, we actually have two conditions: count is greater than equal to 0, and count is less than equal to 100. So we want to check if the count is within the range of 0 and 100. In that case, you will output that if it's true or not. Count is 20, so 20 is greater than equal to 0, yes, true, and count is less than equal to 100, yes, true, hence it evaluates to a true value. Then finally, we have got some character matching here. If A is less than equal to the character and character is less than equal to Z, that evaluates to whatever value is. So character here is capital B. Capital B is, if you remember the character comparison methods, B is greater than equal to A, yes, true, and B is also less than equal to Z, hence true. So this is going to evaluate to a true value. And exactly that is what you see here. So let's go to the next example. In this particular example, what we see is precedence of operators mainly, and also how to compare different things together with each other. So this is an example 4.14 that is a program to determine if additional charges are applied on a suitcase accompanying a passenger on an economy flight. So basically, if you're overweight, you're going to be caught here and you're going to be fined some amount of money. And in this case, what we observe is that we declare the traditional preprocessor directives. We include IOM and IP for basically the setting the precision and using manipulators, etc. We declare some variables. We set the manipulators correctly. We output that the suitcase dimensions are length plus width plus depth in inches. So we ask the user to for the suitcase dimensions, which is going to be a double, right? So the dimensions are going to be sum of all of these. So you just need to enter one number. Then we enter the suitcase weight in pounds. So what is the weight in pounds? If suitcase dimension is greater than 100 or suitcase weight is greater than 50, we put additional charges. Otherwise, there's no additional charge. So this is a single if statement, but inside that we're using the or statement. If either of them is true, you basically put in additional charges. By the short circuit rule, we know that if this is true, then we don't evaluate this. Whatever this is, we just move on to putting in additional charges. And then we say that what is the additional charge? If it's 0 or if it's 50, if it has changed here, it's going to be 50. If not, it's going to be 0 and used here, and the program returns a value. So if I just run the code again for your approval, let's say if I enter the length or dimensions, let's say my dimensions are 200, right? Enter the weight in pounds. Weight in pounds is, let's say, 20. I'm still going to be charged $50 because I'm over the limits here. On the other hand, if I, for example, put in, let's suppose 50 over here, and let's say 55 in weight. I'm still overweight, so I'm going to be charged $50 again. However, now in the third run, if I put, let's say, values of 80 and 40, I'm not going to be charged anything. And that's the way it should behave exactly. And that's a program for you. So moving to the next example, which is example um, chapter 4 example. And here, what I'm trying to do is I'm there's a shape that gets entered. It can be rectangle or circle or cylinder, and based on the shape value, if the shape is rectangle, I then need to calculate the area of circle, which is something that's not that is incorrect, I think. If shape is rectangle, I do not really want to calculate the area of circle, circumference of circle. But if it's a circle, I'm going to calculate these. If it's um, so there is some certain bugs over here. And what are the bugs? Well, things have been mixed up over here clearly. So for example, this is area of a circle. It should be placed inside the area. However, when you enter a rectangle, it basically calculates the area of a circle, circumference of a circle. It asks you to enter the height of the cylinder, and once you enter that, it asks you to enter the width of the rectangle, and then based on the area, height, and width, it calculates the perimeter of the rectangle, which is correct. This one is fine, but the rest is not fine. And also double width is declared here. So how can you use width? It's not, if it's not declared here, you cannot use it. Similarly, this hash include string is incorrectly placed. So this program is full of logical errors and incorrect. The problem here, as you will notice, is a couple of things. If I'm to correct this one, I don't need to include this one here. This should be at the top. The double width should, because it's being used here, it should be declared earlier. Anything that belongs to a circle should basically be in the if shape is equal to circle. This one is dangling. This is nowhere. And similarly, this return statement should be after this at the end of the program. Similarly, C match should be at the top, and blah, 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 blah. So all of these things are problematic. You're declaring constant variable here, which should be at the top. And basically, if you get this program, you should be able to, you know, move it around, fix it up so that it becomes runnable. And this is something that I might like to give you in the exam as well, somewhere or sometime, maybe in the quiz. This is an excellent example for that. If I run it, I'm going to observe a lot of errors. So I'm just going to run it for your reference, and I can observe that it's not going to let me compile. It gives all these loads of errors. Okay, so it's not even compiling. It's not going to run. I need to fix it up. You can do it on your own since you know the basic rules now. Let's go to the next example. And here, this one, yeah, next example. And here, this is the string comparison operators, and we know the rules. So the rule is that if it matches, we can compare to the next character. If it matches exactly to the last character, then we basically just take the smaller one as the smaller length is basically smaller than the larger one. And otherwise, based on character comparisons, it can give you the values until all characters are being matched. It keeps on going to the next character and so on. That's about it. I'll kind of just run the code for you to see the solution here. But yeah, so here it is, the solution. But I'll kind of move on to the next example. We've already discussed that in the lecture. So then here is a program that calculates the weekly wages. This is the simplest program, and what it does is it asks the user for wages, rate, and hours, and based on the hours and rates, it calculates the if hours is greater than 40, the wages are 40 into rate plus 1.5 into rate multiplied by hours minus 40. Otherwise, the wages is hours into rate, and we just output it. So here it is basically something about precedence of operators as well as about if and else statement. And here what we observe is that if R is greater than 40, then the wages will be calculated as first 40 multiplied by rate, then 1.5 multiplied by rate, and then this is multiplied by first R's, you subtract my R's minus 40, and then you multiply it with rate and multiply it with 1.5. Otherwise it's just 40 into rate for the normal one. So this is how it operates. So let's check. If for example for 60 it should be equal to it should be 2 times the rate of 80, right? So let's say if working hours is 60 and rate is, let's say, 100, right? So it gives that for 60 hours I'm going to be paid 7,000, because for 40 hours I'm being paid 4,000, for 20 hours I'm going to be paid 3,000, and hence the total rate is 7,000. However, if I now enter, let's say, a value that is, let's say, 40 hours and let's say again 100, then the rate is now 4,000 because it goes into here, includes it. So this one shows the operator precedence. This one shows it also shows the use of if else, a two-way statement. And that's about it for this particular chapter 4 examples. We have now finished chapter 4, and in this particular chapter, as I just discussed earlier, we have basically discussed the control statements, the switch statements, mainly switch, if else, and how we can make a choice at certain points. We saw an example of assert in the class, although that was something that I wanted to show again now, or that is what we showed in the class. If assert is true, we know that nothing happens, but if assert is false, the program terminates right at that point. And assert statement always contains a condition accompanying it. So with that, I'd like to thank you all for listening to my lecture on chapter 4. In the next lecture, we'll then now discuss the other control structures, which are basically repetition. Thank you very much for listening to the lecture, and I hope you learned something during my lecture. Now I'm going to uh, stop sharing, and I wish you the best of luck for the next lectures. See you in lecture 5 on repetition. All the best.